Okay, so let's have a go at this question. So we've got some elements in the periodic table, and it tells us that the symbols are not the symbols of the elements in the real periodic table. So the first question says, two elements that are non-metals. So if you remember, the metals are always on the left of the periodic table, and the non-metals are on the right. So we're going to go here. Ooh, let's get one on the right. We're going to go here for G and X because they're on the right hand side. Give the letters of terminants in period 2. So remember, periods go across the periodic table. So the first period, put some numbers to help us, is here, and then the second period starts here. So your answer can be either A, E, or G, just two of those to get the mark. Give the letter of an element that normally forms a +1 charge. So if you live in group 1, you form a +1 charge. So here you could have A, or you could have J as your response. This question here is asking us a little bit about isotopes. Let me just, obviously you can see the answer, but I should explain why that's the answer. There are two versions of element E. They both have atomic number of 5. One has a mass of 10, one has a mass of 11. So you can see from this, the atomic number is the same, but the mass number is different. So what we have to say in our response when we describe what is meant by an isotope is that they're atoms of the same element. They've got the same number of protons, but a different number of neutrons. You get 1 mark for saying same protons, second mark for saying different number of neutrons. Okay. Next question says all the atoms of element contain, so they are all going to contain 5 protons. So that's definitely going to be right, but let's just prove why. So this first one here is going to contain 5 neutrons, but this one will contain 6 because it's the difference between these two. They don't contain 6 protons because the bottom number is the proton number, and they both don't contain 6 neutrons. So the only answer is 5. Give the electron configuration when it has atomic number of 18. So if its atomic number is 18, that means it's got 18 electrons. So remember, we go 2 in the first energy level. Then we have 8 in the second, that gives me 10. And then we have another 8, and that gives me a total of 18. And if you check there, this means it's got a full outer energy level, and it fits in because that is a noble gas, and they always have full outer energy levels. Okay, the next question is an empirical formula calculation. Okay, and what we're going to do is work through it together. So let's have a go at this one. So the first thing we do is we write down the mass in each of these questions. So this one is 3.5, and the mass of G is 4. Now to help me, I've written this triangle here because we use this triangle to lead us through the calculation. So I've got the mass. Next thing I write down is the MR. So the MR from the question, so here you can see it tells me that the relative atomic mass for A is 7 and G is 16. So let's put those two numbers in. So A is 7 and G is 16. So now I've got the mass and the MR, I work out the moles. So here we're going to put the moles, and to do that all we have to do is this number divided by this number. So if I get my calculator and I'm going to do 3.5 divided by 7 is going to be 0.5, so that is 0.5, and then 4 divided by 16 is 0.25. Okay, the next step, divide by the smallest number. So of these two numbers we've got, this is the smallest, so I'm going to divide both by that. I'll write that down so you can see what I'm doing. So 0.5 divided by 0.25, and that's going to be 2. And then I've got 0.25 divided by 0.25 is going to be 1. So this means my empirical form is going to be A2, G1. So let's just write the answer down so we complete the question. A2 and then G1, I don't need to put the 1 in. Okay, the final bit, and here it says we've got an oxygen atom's got 6 electrons, hydrogen's got 1, complete the dot and cross to show a molecule of water. So what we have to do here is we know that this is going to be a covalent bond, so it's a shared pair of electrons, there's 2 electrons there. The crosses I'm going to use to represent the oxygen electrons, so I've got 1, 2, and it says it should have 6, so that means I've got 1, 2, 3, 4 more to give me a total of 6 for that, 1 for each hydrogen, and we can see that there's the covalent bonds, and this has got, oxygen's got a share of 1, 2, 3, 4, 5, 6, 7, 8, therefore it's stable. There's my answer.